Hey guys, welcome to Section 5, Chapter 6 of the Algebra 1 program. And this is our final section in this chapter. Everything that we have done in the first 4 sections culminate in this section. So this is one of the reasons I love math. It really builds on itself and it really gives you the opportunity to build a strong foundation as you continue to practice the skills from section into section, and then eventually ending up with this like really awesome skill to be able to assess something. And today for us, that is being able to look at linear functions and decide whether they are parallel or perpendicular lines. So just to review, parallel lines are two lines that never cross, right? They're going to go up at the same speed like this. And of course, perpendicular lines, they form right angles. Okay, this is going to be super helpful for us in the future, but today we're just going to practice all of this great algebra that we've learned, and we're going to be able to evaluate whether two linear functions are parallel or perpendicular. And just to remind you too, I feel like this was something that I don't remember ever being explicit. A linear function is a function that's a line. Function that is a line. It's a straight line, right? So right now in this space, all we're working with are linear functions as we really develop this strong algebraic foundation. Okay, so we know something about linear functions. We've been working with a lot of various forms, right? We've been working with y equals mx plus b. That's our y-intercept form. We've worked with standard form. And then last section, we worked with point-slope form. Equals m times x minus x1, right? We did all of these things, eventually trying to get it into this form so that we could graph it, because in this form we know both the slope and the y-intercept, and that makes our life really easy, right? So we're going to use that information. We're going to get our functions in this section all into y-intercept form, and then we're going to evaluate the slopes, okay? So if two functions have the same slope and different y-intercepts, they are parallel. Okay, so let me show you what we mean here. Let's say we have y equals 4x plus 3, and then we have something like y equals 4x plus 1. We can identify where the slope is in these functions, right? Because we've worked a lot with y equals mx plus b. We know that the m coefficient stands for the slope. And so all we have to do is look. We have to look right here. Both of these numbers are the same, and both of the y-intercepts are different. The reason they have to be different was because if I had y equals 4x plus 3 and then y equals 4x plus 3, they have the same slope and the same y-intercept. It makes them the same line, right? So we want two different lines here, which is why the y-intercepts have to be different. But if we evaluate them, solve for y, and we see that the slopes are the same, then I know that these two lines are parallel. Okay, so that's really not that hard. All right, what if you're given a problem like this? Y equals 4x minus 2, and then we have negative 4x plus 7y equals 28. And you have to decide if these two lines are parallel. Well, this guy is already solved for you. That makes our life really easy, and we know his slope is 4, right? Well, in this guy, though, we need to change him into intercept form in order for us to be able to quickly and easily identify the slope, right? So let's do that. We're going to add 4x to both sides. This is going to be using an old skill, which I'm super excited about here, where you guys are going to have to play around with these functions. So 7y is going to equal 4x plus 28. And then make sure you divide everyone by 7, because otherwise you're going to be misled here and think that these guys are parallel. But in fact, when I solve it and I evaluate the slope here, the slopes are not the same. So they are not parallel. Okay? And that's it. Parallel lines are the easiest lines. All you have to do is check to see if the slopes are the same. All right? We love it, and it, makes us happy. What if you have to write the equation? So now let's say I'm going to write this out. So we want to write the equation of a line parallel to a given line and passes through a given point. All right, what does that all mean? So you're going to be given a function, let's say y equals negative 2x, all right? And you're going to be given a point, 3 comma negative 2. And now we want to write the equation of a line that is parallel to the line given and also goes through this point. All right, we actually have the skills to do this. All right, so in order to write an equation, so in order to be able to write something in y equals mx plus b form, or in y minus y1 equals mx minus x1, we'll accept either, right? You need the slope for sure. And in this case, we're given a point. So we could use our point slope form and be able to write this thing. Okay, so we have our point. We can check that off. Now I need a line that's parallel to y equals negative 2x. Well, remember, parallel lines have the same slope. All right, so what's the slope of this line? The slope is negative 2, of course, right? So now I have my point and my slope, and I can write my form y minus, actually, a negative 2, we'll clean that up, equals my slope, which is negative 2, x minus 3. And now if you have multiple negatives, I want you to definitely clean that part up. Okay, now I want you to clean up this form and always put it in y-intercept form. It's just really good practice. Minus 2 would be plus 4. And life is good when things are in y-intercept form. So I want you to put this in point slope form and then solve it for y. The opposite of that would be perpendicular. Perpendicular lines have negative reciprocal slopes. Now, what do I mean by that? Okay, so for example, if you have a line and the slope was 6/7, then the perpendicular slope is the negative, so I have to switch the sign. In this case, it's positive, so I'm going to make it negative. And I have to flip over the numbers. So it would be negative 7/6. Okay? If I have a slope that's negative 1/2, then the perpendicular slope is going to be a positive 2/1, which is just 2. All right, what if I have a slope that is 3/4? Then the perpendicular slope is negative 4/3. Okay, so perpendicular lines have opposite signs and they are reciprocals. Okay, so the first part of this section, inside the section, is just finding the perpendicular slope of a given line, right? So again, if we were looking at a function, something like y equals 2/3 x plus 3, and they asked us to find the perpendicular slope, all we have to do is identify what our slope is, right, which is 2/3, and then the perpendicular slope is the negative reciprocal of that. Okay. All right, now we're going to do the same thing as above. If we have something that's like write the function of the perpendicular line of the given function with the given point. We can actually do this, which is amazing and super fun. All right, so they give you the function y equals 1/2 x plus 3, and they give you the point 4, 5. Of course, in our minds now, we're going to be thinking, all right, I'm going to use point slope form here. So I got to keep that in the back of my mind. I hope that you're writing these formulas over and over and over again so that you're not having to look them up and they're becoming like really easy to pull out of your memory. Okay, in order to be able to write this, we need the slope, right? And we need the point. So the point x1, y1, which fortunately we already have that guy, right? But now we need the slope of the perpendicular line. So first I have to identify the slope of the given line. So my given slope is 1/2. What would be my perpendicular slope? -2, right? It's the negative reciprocal. So now I have my slope and my point, and I can plug in. Y minus 5 equals -2 x minus 4. And we can solve. Y minus 5 equals -2x plus 8. And y is going to equal -2x plus 13. All right. Not too bad. There's one other piece in this section. Everything builds to this final problem type in your section, and it's super fun, and you're going to practice this a ton, but I want to introduce it. You're going to be given two functions, and you're going to have to be able to identify whether they are parallel, perpendicular, or neither. All right? So for example, if we're given the two functions, y equals 3x minus 8, and then we have the function 3x minus y equals -1, we have to decide, are they parallel, perpendicular, or neither? Well, in order for us to be able to evaluate that, we have to look at their slopes. In order to look at their slopes, they need to be in y-intercept form. Okay, this guy, he's already in y-intercept form. It makes my life easy. But the second guy's not, so we need to rearrange him so he has y equals. So let's do that. So -y is going to equal -3x minus 1. Now we have this -y here, so multiply through by a -1 and flip all the signs. Y equals 3x plus 1. All right, now he's in y-intercept form. Now we can evaluate the slopes. Check your slopes and see, are they the same? Are they negative reciprocals? Are they neither? Of course, in this case, they are the same. Therefore, our lines are parallel. Okay, I'm going to do one more like that. What if I have 3x plus 2y equals -5? And then what if I have y equals 2/3 x plus 6? Are they parallel, perpendicular, or neither? All right, in order to be able to evaluate that, we needed an intercept form. This guy is already in intercept form, so that makes my life easy. But the first guy is not, so let's rearrange him. We're going to subtract 3x from both sides. -5. Then we're going to divide by 2. -5 halves. Now I don't care about those fractions. They don't make me uncomfortable because all I'm doing is evaluating these slopes, right? Make sure that's a negative. And if you notice, this slope is 2/3, and the perpendicular slope would be a -3/2, which is exactly what we have here. Therefore, these lines are perpendicular lines. All right, you guys, I know that was a lot. Please take your time, go through these notes again, finish them up, read through this section, and then we're going to spend a lot of days in the next week or so practicing this to hopefully make you feel comfortable. So when you're ready, begin your assignment.